Okay, solving exponential equations. Cool. So there's 3 steps, and I'm just going to write them down, and then we'll go through some problems. So, 1, use the properties of exponents to simplify each side. So we want to get it down to 1 exponential. And then we have to rewrite them so that they have the same base. And then you drop the bases and set the exponents equal to each other. So if we have 2 to the x plus 1 power equals 2 to the 9th power, well, we've already skipped step 1 and step 2 because they already have the same bases. So we can just drop those bases and set the exponents equal to each other. So you have x plus 1 equals 9, which means x equals 8. And you're done. Okay, let's look at this one. So we have 3 to the k times 3 to the k plus 2 equals 3 to the k, 5k minus 1. Now we have to rewrite those. So if the bases are the same, we are multiplying, and we are multiplying, you can add the exponents. So multiplication equals adding. And think about this like multiplying is really just adding over and over and over again. Like if you have 4 times 3, that's really just adding 4 together 3 times. So that's 4 plus 4 plus 4. Right? So that's a way that we can remember that multiplication equals addition. Okay? So, how do you X out of this? Sorry. We have 3 to the k times 3 to the k plus 2 equals 3 to the 5k minus 1. Well, let's just add those exponents up on the left. So we have k plus 2, which is 3 to the 2k plus 2 equals 3 to the 5k minus 1. Same bases, let's drop them. So we have 2k plus 2 equals 5k minus 1. Subtract that 5k, subtract the 2, so you get negative 3k equals negative 3, which means k equals 1. And you can always plug that back into our original and make sure it works out. So like whatever you get on the left side, make sure that's what you get on the right side also. Okay? Let's look at this one. So we have 6 to the 2x minus 10 equals 36. Now we don't have any exponent properties that we have to deal with, but we do need to rewrite that 36 so it has a base of 6. So we have to think 6 to what power equals 36? Well, it's 6 to the 2nd power. So we're going to have 6 to the 2x minus 10 equals 6 to the 2nd power. Now we have the same base, set them equal to each other, so 2x minus 10 equals 2. Add that 10 over, 2x equals 12, divide by 2, x equals 6. Sweet? Let's do this one. So this is 27 to the 2x plus 6 equals 3 to the 2x. Now we don't have any exponent properties, but we need to get it so they have the same base. And I would always go for the smaller base, like 27. It's hard to get 3 to have a base of 27, but you can break 27 down so it has a base of 3. Because 3 to the 3rd power equals 27. So this is going to be 3 to the 3rd power times 2x plus 6 equals 3 to the 2x. Now we have the same base. Drop them. We have 3 times 2x plus 6 equals 2x. So that's 6x plus 18 equals 2x. Negative 18, or 18 equals negative 4x. So x equals negative 18 over 4, which reduces to negative 9 halves. Cool? Let's do this one. So this one we have a 4 and we have an 8. Now 4 to some power does not equal 8. But we could break 4 down to be 2 squared. And 8 is 2 cubed. So that's what we're going to have to use. So that's going to be 2 squared times 3x equals 2 cubed, times x minus 1. So that's 2 times 3x equals 3 times x minus 1, which is 6x equals 3x minus 3. Subtract that 3x, so you get 3x equals negative 3, x equals negative 1. Cool? Now we're getting a little complicated, not too much though. So we have 4 to the 2x times 1 over 16 equals 4 to the 6x plus 18. Now we have 2 bases of 4s. The 1 over 16 is what I need to change. Well, 4 to the negative 2nd power equals 1 over 16. And we need to get into negative exponents here. Let me move positions because I'm going to have to start writing. All right. So if you have a negative exponent, this is something that you guys need to understand. let's just start with, let's do 2's, okay? So let's start with like 2 to the first power. That equals 2, right? 2 squared equals 4. I want to write this a little bit differently. Okay, so let's write it this way. So 2 to the first power equals 2. 2 squared equals 4. 2 cubed equals 8. We can keep going with that, like 2 to the fourth equals 16, blah, blah, blah. Now, what are we doing every single time we come back here, right? We're dividing by 2. Here I divided by 2. We're going to do the same thing, so 2 to the 0 power, 2 divided by 2 is 1. So anything to the 0 power is 1. Now if we go into the negative exponents, we have 2 to the negative first power, divide that by 2, that's 1/2. 2 to the negative second power is 1/4, because you're dividing by 2 again, which is the same as multiplying by 1/2. Again, 2 to the negative third power is 1/8. Another way that you can think about that, so if we have 2 to the negative second power, this negative exponent is going to drop it down to the base, so this is going to be 1 over 2 squared, which is 1 over 4. Okay, so there's a couple ways to think about that. If you still have questions, I will definitely go over this with you if you want me to, but you just got to come ask me. Okay, but hopefully that helps you understand negative exponents a little bit better. So if I know that 4 to the negative second power equals 1 over 16, because 4 squared equals 16, so you just move that to the bottom, I can plug that in right there. Now multiplying is the same as adding, so this is going to be 4 to the 2x minus 2, because if you add a negative, it's just a subtraction, equals 4 to the 16x plus 18. So you get 2x minus 2 equals 16x plus 18. Solve that, you get negative 4x equals 20, so x equals negative 5. Cool? All right, now, what is the base of e? E is an irrational number with an approximate value of 2.71828. It occurs in exponential and logarithmic functions that describe real-world scenarios. Now, I am not going to pretend to know that I know where e comes from. Hopefully I get to the point where I can explain it. It's kind of like the number pi. It pops up in nature a lot, and it's just this cool number that seems to pop up everywhere and explain a lot of things. I'm not 100% sure where it comes from, though. Really sorry. I will try and find out if it's important to you. Okay. Exponential functions with the base of e are called natural base exponential functions. Okay, so e is the natural base. It occurs naturally, which kind of makes sense. An example would be f of x equals e to the x. Okay, now logarithmic functions with bases of e are called natural logarithms. So it's same as the exponential, it's just natural base, natural logarithm. An example would be like log base e of x. And there's actually, this pops up so often in mathematics that there's a button for it. So it's the ln of x. ln is the same as log base e. Okay, you guys need to make this connection that this and this are the same. Okay? Let's see. So if we write these as logarithmic functions, that's log base e of 24 equals x, which is ln of 24 equals x. That's ln of x equals 9. ln of 72 equals x plus 5. Now if we switch these to exponential form, that's log base e of x equals 58. Draw that e, so that's e to the 58th power equals x. This would be e to the 6th power, or e to the x power equals 6. E to the 32nd power equals x minus 9. Okay, condensing them, again, addition goes with multiplication. I want you to do this part. So addition goes with multiplication, subtraction goes with division. And then when you have a number in front, so like 3 ln of 9, that just moves to become a power. So that'd be ln of 9 cubed. Okay, you guys can do this part. I'm pretty sure I put the answers on here. Let's check. Yep, they're there. Okay, so if you get them wrong, ask me in class. I'll explain it to you. And, yep, remember to take the quiz. Goodbye, you guys rock.